We'll go ahead and get started. It's good to see you guys again. So he said that you guys specifically asked for matrices. Hello, coming in. And the equations of circles. Just tell me. Oh, it's all right. Don't lose those though. Fill me in on the testing stuff that you've done. Have you just gone in order through the tests, or how does it work when you've done this book? He just kind of says take this number, or have you worked in order front to back? You don't even know? No. Well, so I was just taking the opportunity to flip through it and see what was going on. I was seeing about 1 or 2 circle problems per test, maybe 1 matrice problem per test. And so they will likely be on there, but it's not going to be a huge chunk of it. And so it's good for your information. It's not hard per se, but it's not going to be, oh, there's a matrix problem every other page. So, first of all, have you seen matrices is the plural? Have you seen them at all before? A couple of nods, mostly no's. So, a matrix is a way of organizing information. If you can think of, if you've ever had to work with Excel, Microsoft Excel, you're going to have rows of information and columns of information, and usually this is going to be done with numbers. Especially in math, obviously, it's going to be numbers. So, just like coordinates, we had our x side-to-side direction and then y up and down. You are going to do rows, then columns. And so the more that you know which one comes first, the easier things get. So we're going to do rows first and then columns. And so when we say list the dimensions of each matrix, it's just the number of rows by the number of columns. So A has 2 rows, 3 columns. It's a 2 by 3 matrix. So what would the size be for the other 3? My handwriting changing side to side. This is also 2 rows, 3 columns, 2 by 3, 3 rows, 2 columns, 3 by 2, 2 rows, 2 columns, 2 by 2. So, similar to a coordinate pair again, if I ask for the value of C21 or C21, what number do you think that is? Remember, rows, then columns. This is going to be row 2, column 1. What is our value? Just don't feel chatty. We have row 1, 2, column 1. So C21 is going to equal 1. It's just the piece of information in that location. So all of this is on page 12, if you're looking at the book. So that's the general gist of matrices. It's going to be numbers arranged in rows and columns. You have the dimension of rows by number of columns, and the location of a particular element of the matrix is given letter of the matrix. They're labeled with uppercase letters, and then go to that row, that column, that piece of information. So for instance, D22, we go to matrix D, row 2, column 2, D22 equals 0. So 3 jumps a little bit. So before we do 3, we're going to talk about what a scalar is. If you think about a recipe and I tell you we're going to double it, what does that mean? Times 2. What do we times 2? Everything. And so for scalar multiplication, this 2b means to take b and multiply everything in it by 2. So 2b is going to equal 16, 10, negative 2, 0, 0, 6. So that's the scalar. If they throw a number out in front, everything inside that matrix is getting multiplied by that number. The second one is, how do we add these? So, first and foremost, in order to be able to add them, they need to have the exact same dimensions. And so the good news is both A and B are 2 by 3. Since they are the same dimension, they're going to have stuff in the same location. And so we can take 0 plus 0. Our answer will have a 0 down here. We can take 3 plus 16. That 1 element is going to be 19. We can take 0 plus 10. We have 10. So go ahead and fill in the rest of what those values would be. And I apologize for scattering it across the board. Hello, my phone was vibrating enough. I'm just going to try and end it and start it again. Hello? Okay. So I'm on today, start. I'm trying once more. No, the participants have just me. So if I press invite, oh no, I see people. Woohoo! Bye. Tech, gotta love it. Admit. Admit. All right. Start the video. Anyone else coming? All right, I apologize for the tech difficulty. I have no idea what was going on. So, catching up, we're working on matrices. Matrices are organized numbers, and matrices are labeled with an uppercase letter, and they are given a size or a dimension by their rows and columns. And so this has 2 rows, 3 columns. This also does 2 rows, 3 columns. This has 3 rows and 2 columns. And this one is a 2 by 2. We were talking about the dimensions. Finding a specific value is going to give you the matrix and then have the row number and column number, again, rows then columns. And so item C, or element C, is in row 2, column 1. We had row 2, column 1, and that looks like a negative. I should not draw tick marks. So we were talking about adding 2 different matrices, and then we were talking about what 2b meant. 2b was a scalar, and so we multiplied everything in b by 2 to get 16, 10, negative 2, 0, 0, 6. And then we were about to start adding them together, a and b. So, important piece of information, in order to be added, they have to be the exact same dimensions, because you're going to be adding the corresponding elements, or the things that are in the same location. So 1, 1 of A was 3, 1, 1 of 2B was 16, and so added together they were 19. 0 and 10 was 10, 2 plus negative 2 would be 0. 0 and 0 is 0, negative 3 and 0, negative 3, and 1 and 6 would be 7. So, of the set of 4 matrices that we have to start with, are any of them able to be added except A and B? Can we add any others together? No, because they are different dimensions. And so it's only possible to add them together when they are the exact same. You may see these mixed in with other algebra type solving. They'll give you X and Y inside the matrice, and so you have to start there with finding the equation, and then you'll have to solve from there. So, if we had a ACT question that just said, which one of these operations is possible. And they have a mix, I'm not going to write it out, but it's 2b plus c, c plus d, b plus c plus d, 2a plus c, or 2a plus b. Again, really quick, we know that a and b are the only ones that are the same size. And so those are the only operation possible. You don't have to try and sit down and start writing it out and adding it. You can just jump to, those are the only ones with the same dimension. Those are the only ones I can add together. Okay? So, looking at the middle of the page, on page 12 is where we have the matrices. We already talked about scalar multiplication, which is just the idea of multiplying everything in the matrix by that same number. The question is then product of matrices, which is the B part of the multiplication. This, he has a little bit, but the chances of them asking you to multiply, it's not zero. It is a very long process, and so they probably won't ask you to multiply out the whole thing, but it's possible that you would be multiplying something very small. And so I want to talk about what's going on with multiplication. So he emphasizes that matrix A and matrix B, the inside dimensions have to be the same. And so we're going to talk about that first. In order for this multiplication to be possible, matrix A times matrix B is not possible. They have to have the inside dimensions the same. And so we can talk about A times C is possible because we have 2 by 3 and we're multiplying that times a 3 by 2. And so these inner dimensions being the same make it possible. So that was an A times C. And it's just written together the same way. Multiplication is always written together. So the 3's are the same. Our final answer is going to be 2 by 2. And we'll talk about why in a little bit. Order makes a huge difference. We are so used to multiplication, you can just flip it around and it doesn't make a difference. In matrices, it makes a huge difference. Because if I put C times A, C is a 3 by 2, and A is a 2 by 3. The insides are the same, so it is possible, but my final answer is going to be 3 by 3. And so the order on matrices, again, makes a huge difference. Doesn't have to have this mirror effect. I can take D and multiply it by B because D is a 2 by 2, B is a 2 by 3. These two are the same. Our final dimensions are going to be 2 by 3. And so, if you can remember that in order to multiply matrices, their inside dimension has to be the same, that will probably be enough to get you 1 problem out of 3 on matrices, just understanding that concept. Whether they have you actually do it or not, that's going to be less common because it's just too time consuming. Matrices are mostly done by computers. They can be done by a graphing calculator for the most part, but you still have to know how to run it, and it still takes a lot of time to enter the information. The concepts are taught with these 2 and 3 matrices. In reality, when you're using a computer and actually using it to create answers, they're going to be things like 7 equations long, 7 variables, lots of information. So, oh, I forgot to grab an eraser. I will be back in 2 seconds. The question is, what's actually happening when we multiply a matrice or a matrix? So, we're going to do B times C. We've already stated this is a 2 by 3 times a 3 by 2. These two are the middle. Our answer is going to be 2 by 2. Again, the rows and columns have a great influence. We are going to get each piece using the rows and the columns. We're going to use the row of the first matrix and the column of the second matrix. And so that's why those inner dimensions have to be the same. We need 1, 2, 3 to match with 1, 2, 3. What we are going to do, because this is multiplication, we are going to multiply each piece and just add them together. That's what's going on with matrix multiplication. So we're going to take 8 times 2 is 16, plus 5 times 1 is 5, plus negative 1 times 0 is 0. And so our first element is 21. So with matrix multiplication, again, the rows and columns make a huge difference. That tells you where you're getting it, but it's a matter of multiplying the corresponding pieces and adding it all together. So for the second one, second row, first column. That tells us we need to use the second row, the first column. We're going to take 0 times 2 is 0. 0 times 1 is 0. 3 times 0 is 0. Our second element right here is 0. Does that make any sense at all? Okay. So if they ask you to multiply there, you are looking at the row and the column of what you want the answer to be. This is the first row, second column. So we're going to take our first row, but now we've moved on to the second column. And again, we're not going to do that out. But this is why it's possible to take D times B. Remember, D is a 2 by 2. B is a 2 by 3. This comes out of the middle. Our answer is going to be 2 by 3. and it's always easier to give yourself blanks to fill in. If you know what size you're going for, it's easier than trying to generate it from the beginning. So we are taking D, row 1, times column 1. So we have 4 times 8 is 32. 2 times 0 is 0. If we want this last one, this is the second row, third column. Second row, third column, it's just matching pieces of information up. All right. So, other than the ones I showed you, B times C and D times B, what is another pair of multiplication that is possible? Or rather, if I say C times B, is that possible? What will our size be? C is a 3 by 2. B is a 2 by 3. The middles cancel out. Our answer will be 3 by 3. How about CD? Is that possible? Yeah, because they both have this 2 in the middle. Our answer will be 3 by 2. So, DB was possible. Is BD? No, because B is a 2 by 3, D is 2 by 2, not a match, not possible. All right, go into your practice test book. It's on page 286. And it's the bottom of the page, number 59. be on a different problem. Practice test?
Yeah. I forgot a different book though.
Oh. Wait.
Which test is it? Is it Mathematics 4?
Yeah.
Okay, what is 50?
Mm-hmm.
Which one?
No, it's very different. That's interesting.
I don't know, Sam, I don't know, it's something.
It's alright. If you just want to look at this one, you can.
Okay.
It's just like, that does not look like matrices. So, if you don't have the blue book, it's different. So, if you did have the blue book, which one of those is not possible? RT, the last one. Because you just compare what number would be in the middle. They don't give you the numbers, they don't give you a lot, they're just conceptually asking you, is it possible to multiply these? And you just have to compare those center numbers. Alright. So, the last thing I have to go over with you for matrices is just them thinking they're clever. So do you have any questions for matrices before then? Again, knowing whether it's possible to add or subtract matrices, understanding what the scalar does, and knowing whether it's possible to multiply the matrices, that is probably going to show up a lot more than actually find the answer. A lot of these are going to be very conceptual rather than actually doing the procedure, just because the procedure is a little time consuming and they're aware of that. So, last thing as far as notes, I believe if they talk about the determinant, they're going to give you this formula, but I'm not certain. Given a matrix A, the determinant is going to be kind of like tall absolute value signs. So if they ask for the determinant of a matrix, it looks like tall absolute value signs. It can also look like this. And so the determinant can be written with the actual matrice information. It's just the solid straight lines rather than the brackety ones. And it equals AD, so the diagonal, minus BC. And again, they might ask you to generate the value for it, but from my research, I wasn't finding a whole lot of problems that use it. If you've done, do they still do this in Algebra 2, or is it more pre-calc now? Okay. I lose track of where what fits compared to 20 years ago. So, I think they shuffled it to pre-algebra, but this can be used to solve two equations, two unknowns, systems of equations, and it can also be used to do three equations, three unknowns, which can be quite messy without it. And so that's where that one will come up. The final one, like I said, they seem to be just delighted in their cleverness. It's not hard, but it does capture the idea of what they might throw at you as far as, haha, we're funny. So they have asked you to evaluate 2x plus y plus 4z given So, I've shown you with the letters, but do you know what this positioning even is asking? Okay, this is multiplication. We have a matrix that is 1 by 3, 1 row, 3 columns, and a matrix that is 3 rows by 1 column. They are being multiplied together and getting an answer that's the resultant 1 by 1, which is the answer 18. So, knowing that, can you multiply this out? Ignore this part for a second, but just multiplying this, we are going to take the first row by the first column, first and only row by first and only column. We multiply each piece, and then we add them together. In this case, we can't combine them, so we're going to leave it as an addition problem. We have x times 6, that equals 6x, plus 3 times y is 3y, plus z times 12 equals 12z. All of this is equal to 18. That's the matrix part. Just the idea that if you see this setup, they're talking about multiplication. We're going to be multiplying first piece by first piece, middle piece by middle piece, last piece by last piece, and they're all strung together with addition. So, they're asking for this if we have this. Again, this is them being delighted with their own cleverness. It's not hard, but it can look a little tricky. So we have 6x plus 3y plus 12z equals 18. We want 2x plus y plus 4z. How does a 2 compare to 6? Or what would we do to 6 to get back to 2? 3y divided by 3 is y. 12z divided by 3 is 4. And so we are going to divide everything by the 3. So 6 divided by 3, 2x. 3 divided by 3, 1y. 12 divided by 3, 4z. 18 divided by 3 is 6. So 2x plus y plus 4z is 6. Again, the chance of that tricky a problem being on there is kind of slim, but I liked it because it does demonstrate what's going on with that multiplication. And it's entirely possible they could give you something like this and like this without the matrices being thrown in there. Just understanding that you can manipulate a whole equation can be really useful. Just try and make the connection of, okay, I have this, how do I get it back to what they asked for? Consequently, if we flip-flop these, just to review that multiplication again, our result would be a little bit nonsense, but it's good to talk about the concept again. If we have the matrix 6y12 multiplied by x3z, how big would our answer be? What would the dimensions of our answer be? 3 by 3. We have 3 rows, 3 columns. And so again, that order makes a huge difference. Now, we are talking about first row, first column. Our first row is only 6. Our first column is only x. Our first element is only 6x. There's no adding at all. There's just first row has one item, first column has one item. We multiply them together and get that element. So, understanding how to do it can help. So the last thing that we have for today is flipping back to page 11. This one, not hard, does show up. Coordinates and the equations of circles. So, you may not have seen the equations of circles yet. I think that one shows up in Algebra 2. But, do you remember back to equations of parabolas, particularly in vertex form? Where we had y equals a x minus h squared plus k. And you remember that the vertex is at h, okay? For circles, we're going to be playing off that a little bit. The formula of a circle, rather than y equals, is going to be some constant number. And it's going to equal x squared plus y squared. But this constant number isn't just any random number. It's in fact the radius squared. And so the radius of your circle is going to be the square root of whatever number's all by its lonesome. And just like we could have x minus h told us where that vertex in a parabola was, in a circle, our radius squared is going to equal x minus h squared plus y minus k squared, where h, k is the center of the circle. I marked an easier one, but I don't, so we're going to save the example for later. So, if we have just this equation, they might just ask you, what's the radius? How would we find the radius? formula says that the radius squared equals x minus h squared plus y minus k, or the more basic one, this will be centered at 0, 0. But in either case, if they just ask you for the radius, all of this stuff doesn't matter. It's just the square root of 25, which is 5. And so the radius is 5. Where would the center be? Rather than trying to remember this and this was centered at 0, 0. If there's no change, it's centered around the origin. If instead there is these changes in the horizontal and the vertical direction, your center is going to be what makes them 0. What makes this 0 is positive 2, or the opposite sign. What makes this 0 is negative 4, or the opposite sign. So, ACT question might be, does the point 2, 9 lie on the circle? You could check that, okay, is 2, 9 a distance of 5 away from the center? Or you can go more strictly algebra and just check, okay, if I put in 2 and 9, do I get 25? 2 minus 2 is 0. 9 plus 4 is 13. 13 squared is definitely not 25. And you're done. If it had been 2 negative 9, 2 minus 2 is 0. Negative 9 plus 4 would be negative 5. Negative 5 squared is 25. And that one would be true. And so understanding lie on the circle, just know that it's what makes this equation true. Any drawing, whether it's a line, a parabola, a circle, a hyperbola, all that line means is this is the collection of points that makes this equation true. Anything on that line is true, anything off that line is not true. And it would give you a false answer like 13 squared equals 25. All right. Got about 5 minutes left. Any questions at all? I know I threw a lot at you today. We're getting down into the weeds of this is the stuff you might see, but there's no guarantee. There's just a guarantee that there's going to be 1 or 2 of them. All right, so again, in the blue practice test book, so that one, go ahead and go to page 36, number 47. We'll see if that one cooperates. Is it asking about circles? Good. All right.
Already did it well.
Did you do it right?
Yeah.
Awesome. So we have a circle in the standard xy coordinate plane is tangent to the x-axis in 4 and tangent to the y-axis at 4. So we've got our circle and it's coming and being tangent right at here. So we've got our circle there. If they're tangent, the right angle, what would the coordinate of our center be? 4, 4, because it's over 4, up 4. How do we get that into our equation of a circle? It's going to be x minus the x coordinate, y minus the y coordinate. And then finally, what is it equal to? 16, because of the radius squared. Our radius is 4, but it equals radius squared, or 16, for the final number. All right, with that, you are on break for the next 5 minutes, and we will, well, I will not be back. You will be back in this room.